Tonight, a correction to something you were taught, and it is going to unravel into one of the deepest ideas in physics. You know the rule: nothing can travel faster than the speed of light. It is one of the few pieces of physics that everybody carries around, and it is true, and it is also named wrong in a way that hides what is actually going on. Because that number, that famous limit, is not really about light at all. Light has nothing to do with it. Light merely happens to travel at that speed, and it does so for a reason so mundane it is almost disappointing. If light had never existed, if there were no such thing as a photon anywhere in the universe, the limit would be exactly the same, sitting exactly where it sits, governing everything. We named the universe's most fundamental constant after the first thing we noticed moving at it, which is a bit like naming the sound barrier after the first aeroplane that broke it. Tonight, I want to take that number apart and show you what it actually is, and the answer is much stranger and much more beautiful than a speed limit. It is not a rule about how fast things can go. It is the exchange rate between space and time. It is the reason the past and the future are different things. And once you see what it really is, the strange parts of relativity, the slowing clocks, the shrinking distances stop being weird and start being obvious. By the end of tonight, you will understand why the universe must have a number like this, why it could not simply have been infinite, and why almost everything about you depends on its precise value. Now, let's begin. Before we go into it, settle in properly. Let your shoulders drop away from your ears. Let the day finish letting go of you, and let your breathing find whatever pace it wants without supervision. Perhaps the room has been dark a while now. Perhaps you are somewhere on a long night, waiting for morning. Wherever you are, this is a good place to be, and there is nothing here you have to follow or hold on to. Tonight is a slow unpicking of one number, and if sleep arrives partway through, that is precisely what it is for. Let us start with the naming problem, because everything follows from clearing it up. Physicists write this constant as a single letter, the letter C, and they do not usually call it the speed of light when talking to each other. They call it C, and increasingly, when they want to be honest about what it is, they call it the speed of causality. That phrase is worth holding on to for the whole night, not the speed of light, the speed of cause and effect. Here is why light gets the credit it does not deserve. In our current understanding, particles come in two kinds for this purpose. Some have mass and some do not. The ones with mass, which is essentially everything you have ever touched, can never reach C, no matter how much energy you pour into them, because the closer they get, the more energy each additional increment demands, and the requirement runs to infinity at the limit itself. That is the wall everybody knows about. But the massless particles have no choice in the matter at all. This is the part that surprises people. A massless particle does not accelerate up to C and then cruise there. It cannot travel at any other speed. It is born at C, it exists at C, and it stops existing rather than slowing down. There is no massless particle anywhere in the universe going slower, and there never has been. For a massless particle, c is not a limit. It is the only available option, and the photon, the particle of light, is massless. That is the entire reason light travels at the speed of light. Not because light is special, because light is weightless, and weightless things have exactly one speed, which means the name is backwards. We should not say that c is the speed of light. We should say that light happens to travel at c, because it is one of the handful of things in nature with nothing to slow it down. And here is how we know this is the right way round rather than a philosophical preference. Light is not the only massless thing. Consider gluons, the particles that carry the strong force and hold the insides of atomic nuclei together. Massless. They travel at c. Consider, most beautifully of all, gravitational waves. When two extremely heavy objects orbit each other and collide, they shake the fabric of space-time itself, and that shaking spreads outward as a wave. That wave is not light. It is not electromagnetic in any sense. It is a ripple in the geometry of the universe, and it travels at c. Sit with that for a moment, because it is the whole argument in one fact. A disturbance in the shape of space, containing no light whatsoever, made of nothing but distorted geometry, travels at precisely the speed we named after light. If c were really a fact about photons, there would be no reason on Earth for gravity to obey it. Gravity is a completely different phenomenon, described by a completely different piece of physics, carried by a completely different mechanism. Unless, of course, c was never about light in the first place. Unless it is a property of space-time itself, a rule about how quickly anything at all can propagate from here to there, and light and gravity are simply two of the things that go at the maximum because nothing is holding them back. That is the correct picture. And remarkably, we have tested it with an accuracy that is difficult to comprehend using an event that happened 130 million years ago. The event was a collision between two neutron stars in a galaxy roughly 130 million light-years away. Neutron stars are the collapsed cores left behind by exploded suns. Objects with more mass than our sun crushed into something the size of a city. And when two of them spiral together and merge, the result is one of the most violent events the universe produces. That collision did two things at once. It shook space-time, sending gravitational waves outward in every direction, and it produced an enormous burst of gamma rays, which is light, at the extreme high-energy end of the spectrum. Both signals left the same place at essentially the same moment, and then they raced. They raced for 130 million years, across a distance so large that when they set out, the dinosaurs were still comfortably in charge of this planet, and by the time they arrived, we had built instruments to catch them. Think about the length of that race. 130 million years of traveling side by side through intergalactic space, through the outskirts of galaxies, through gas and dust, and the warped gravity of everything they passed. In August of 2017, the gravitational wave detectors on Earth registered the shudder of that merger, and about 1 7/10 of a second later, gamma-ray telescopes in orbit recorded the burst of light, 1 7/10 of a second, after 130 million years. And even that tiny gap is not thought to be a difference in speed. The best understanding is that the two signals were not released at exactly the same instant. The gravitational waves come from the merger itself immediately. The gamma rays come from a jet of material that has to be launched and organized after the collision. And that takes a moment, so the delay is probably the collision clearing its throat, not gravity outrunning light. When physicists worked out what that timing permits, they arrived at a constraint that I find genuinely staggering. The difference between the speed of gravity and the speed of light, if there is any difference at all, is smaller than about 1 part in 1,000 million. Read that as an image rather than a number. Two runners set off together, ran for 130 million years and crossed the line so close together that the gap could be explained entirely by one of them tying a shoelace at the start. So gravity travels at the speed of light to a precision that beggars belief, and gravity is not light, which settles the question. The number is not a fact about photons, it is a fact about the universe, and photons are simply obeying it. Now, having established what C is not, let us go and find out what it is. And to do that properly, I want to go back to the moment humanity first discovered that light has any speed at all, because for most of our history, we did not think it did. The natural assumption, and it is a very reasonable one, is that light is instantaneous. You open your eyes and the world is simply there. You uncover a lamp and the far wall lights up with no perceptible delay. Every experience anyone has ever had of light suggests it arrives immediately, and the greatest thinkers of antiquity mostly concluded exactly that. Aristotle argued light was not a movement at all. Descartes, as late as the 1600s, was so certain light was instantaneous that he staked his entire philosophical system on it, arguing that if light took time to travel, we would see eclipses out of position, and since we do not, it does not. There had been attempts to test it. Galileo, characteristically, actually tried. His method was to station two people on distant hilltops at night, each with a lantern and a shutter. The first uncovers their lantern, the second, upon seeing the light, immediately uncovers theirs. Time the round trip, subtract human reaction time, and you have the speed of light. It is a completely sound experimental design, and it was doomed from the start because light crosses a few miles of hillside in tens of microseconds, and human reaction time is a couple of tenths of a second, roughly 10,000 times longer. Galileo, to his enormous credit, reported the result honestly. He said that if light was not instantaneous, it must be extraordinarily rapid, and that his experiment could not resolve it. He had built a stopwatch to time a bullet, and could only conclude the bullet was fast. The answer, when it came, did not come from a laboratory. It came from looking at Jupiter. The man who solved it was a Danish astronomer named Ole Rømer, working at the Paris Observatory in the 1670s, and he was not trying to measure the speed of light. He was trying to solve a practical problem about clocks. Here is the situation. Jupiter has 4 large moons, which Galileo had discovered decades earlier, and the innermost of them, Io, orbits Jupiter quickly, going round in about 42 hours. And on every orbit it passes into Jupiter's shadow and is eclipsed, disappearing and then reappearing. That regularity was enormously valuable, and for a very practical reason. A predictable celestial clock, visible from anywhere on Earth, was a possible solution to the longitude problem, which was the great navigational challenge of the age. If you knew the exact time in Paris and the local time where you stood, you could calculate your longitude, and Io's eclipses were a clock in the sky that everyone could see. So astronomers set about tabulating Io's eclipses precisely, and they immediately ran into an infuriating problem. The eclipses would not keep time. Over months they drifted. Sometimes Io emerged from Jupiter's shadow earlier than the table said, sometimes later, and the discrepancy grew and shrank in a slow cycle that nobody could explain, and it was large, minutes rather than seconds. Römer, going through the observations, noticed the pattern. The eclipses ran late when Earth was far from Jupiter and early when Earth was close, and the size of the effect tracked the changing distance between the 2 planets as they moved around their orbits. And he made the leap. The eclipses were not drifting. Io was perfectly punctual. What was changing was how long the news took to reach us. When Earth is on the far side of its orbit, the light carrying the image of that eclipse has further to travel, and so the event appears to happen late. Light was not instantaneous. It had a speed, and the extra distance across Earth's orbit was enough to make a measurable difference. Then he did the thing that makes this real science, rather than a clever notion. He made a prediction. In September of 1676, he told the Royal Academy of Sciences in Paris that the eclipse expected in November would not arrive on schedule. It would be about 10 minutes late. Imagine the confidence of that. Standing in front of the assembled astronomers of France and telling them that the sky was going to be wrong by a specific amount on a specific date, for a reason nobody accepted. The date came. The eclipse was late, essentially exactly as he had said. His value for the speed was too low by roughly a quarter, largely because the size of Earth's orbit was not accurately known at the time, so the distance he was dividing by was off. But the number was never the point. The point was the fact. Light takes time. The universe is not showing you the present. There is a delay built into seeing, and it is not a flaw in your eyes. It is a property of reality. Everything else tonight descends from that 1676 observation. And I find it lovely that it came not from a philosopher reasoning about the nature of light, but from a working astronomer irritated that his tables would not behave. Now, let us jump forward 300 years, because the story of measuring C has an ending that almost nobody knows about, and it is genuinely peculiar. After Römer, the measurements got better and better. Bradley found a different astronomical method in the 1720s. Fizeau in the 1840s finally did it in a laboratory, using a rapidly spinning toothed wheel and a mirror miles away, chopping a light beam into pulses and timing the round trip. Foucault refined it with rotating mirrors. Michelson spent decades of his life on it and got the value to within a whisker of the modern figure. By the middle of the 20th century, C had been measured to extraordinary precision. And then, in 1983, the world's weights and measures authorities did something that ended the whole enterprise. They stopped measuring it. Not because they gave up, because they realized the measurement had become circular in an interesting way. To measure a speed, you need a distance and a time. Time we can measure with atomic clocks to a precision far beyond anything else in metrology. Distance, the meter, was defined in a much clumsier way and was the limiting factor in the accuracy. The measurement of C was no longer really telling us about light, it was telling us about the imprecision of our meter. So they inverted the whole thing. They declared that the speed of light is exactly 299,792,458 meters per second by definition, and then defined the meter as the distance light travels in one part in that many of a second, which means something strange and permanent. The speed of light can never be measured again, not because we lack the equipment, because it is now a definition, like the number of centimeters in a meter. Any experiment you run to determine C is now, in effect, an experiment to calibrate your ruler. If your apparatus gives a different answer, your apparatus is wrong by definition, and the length of your meter is what was in error. The most famous measured quantity in physics became a fixed constant of bookkeeping, and the meter, which used to be a bar of metal in a vault in France, is now derived from light. We took the thing we spent 300 years measuring and made it the yardstick for everything else. There is a chapter between Roma and everything modern that I have skipped over, and it is the most important failed experiment in the history of science, so let us do it properly. Through the 1800s, physicists worked out that light is a wave. That was a triumph, and the evidence was overwhelming, but it created a problem that seemed unanswerable, because every wave anyone had ever studied was a wave in something. Sound is a wave in air. Ripples are waves in water. A wave, by definition, is a disturbance traveling through a medium, and you cannot have the disturbance without the stuff being disturbed. So light must be a wave in something too. And since light crosses the vacuum of space from the stars, that something must fill all of space, including the apparently empty parts. They called it the luminiferous ether, and it was not a fringe idea. It was the mainstream position, held by essentially every physicist of the era, and it was entirely reasonable given what was known. The ether had to have strange properties. It had to be rigid enough to carry waves at enormous speed, since wave speed goes up with stiffness, yet so thin that planets could plow through it for billions of years without slowing. That was uncomfortable, but nobody could see an alternative. And it made a clean prediction. If space is filled with a medium and the Earth is moving through it, then we are flying through an ether wind. Light, traveling with that wind, should measure slightly faster than light traveling across it, exactly as a swimmer crossing a river takes a different time than one swimming upstream and back. Earth moves around the Sun at about 67,000 miles per hour, so the effect would be small, but it should be there. In 1887, in Cleveland, Ohio, Albert Michelson and Edward Morley built an instrument to find it, and it was a beautiful piece of engineering. They split a beam of light in two, sent the halves down long perpendicular arms, bounced them off mirrors and recombined them. If one arm was aligned with the ether wind and the other across it, the two beams would return slightly out of step, and recombining them would produce a visible interference pattern that would shift as the apparatus was rotated. To eliminate vibration, they floated the entire apparatus on a pool of liquid mercury so it could be turned smoothly through every orientation. They took readings at different times of day and different times of year so that Earth's own motion would present the ether wind from every possible angle, and they found nothing, not a small effect, not a marginal one, nothing. The interference pattern did not shift. Whichever way they turned the instrument, whatever the season, light took precisely the same time to travel in every direction. It is difficult to overstate how disturbing this was. The experiment was sensitive enough to detect an effect several times smaller than predicted. It was repeated, refined, and repeated again by Michelson and by others with steadily improving precision for decades. The answer never changed. There is no ether wind. Michelson himself considered it a failure and was disappointed by it for years. He had built a magnificent instrument to measure something, and it had measured nothing. He later received a Nobel Prize, the first American to win one in the sciences, largely for the optical precision work that this failure was part of. And the reason it matters so much is what it implies. If there is no ether wind and light comes out at the same speed no matter how you are moving, then the speed of light does not add and subtract with the motion of the observer the way every other speed in the universe does. Throw a ball from a moving train and the speeds add. Shine a torch from a moving train and somehow they do not. That is not a small anomaly. That is a direct assault on the most basic intuition anyone has about how motion works. And for nearly 20 years, the best physicists in the world tried to explain it away without giving up the ether. They proposed that objects physically contract when moving through the ether by exactly the amount needed to hide the effect. That is not a joke. It was a serious and mathematically developed proposal, and it worked in the sense that it made the numbers come out. It just required the universe to be conspiring to prevent the measurement. The situation needed somebody willing to take the result at face value rather than patching around it, and to ask what the universe would have to be like for that to simply be true. The person who did it was working in a patent office in Bern, and in 1905 he published a paper that resolved the whole mess by refusing to solve it. Einstein's move was not to explain why light behaves oddly. It was to stop treating it as odd. He took two statements and simply asserted them as principles, and then followed them wherever they led. The first was Galileo's old one. The laws of physics are the same for everyone moving steadily. There is no privileged state of rest. The second was the one that costs everything. The speed of light in vacuum is the same for every observer, regardless of the motion of the source or the observer. That second statement is not an explanation, it is a refusal to explain, elevated into a foundation. He did not say why light behaves that way. He said, "Let us suppose it simply does, and see what the universe must be like as a consequence." And the consequence is that something else has to give, because you cannot have all observers measuring the same speed for light and also have space and time behave the way everyone assumed. Speed is distance over time. If everyone agrees on the speed, but they are moving differently relative to each other, then they must disagree about the distances and the times. So that is what Einstein concluded. Not that light is strange, that distance and duration are not absolute. Moving clocks run slow. Moving objects contract along their direction of travel. Simultaneity depends on your motion. All of it falls out, not as separate discoveries, but as forced consequences of taking the constancy of C seriously. It is worth appreciating what a genuinely radical inversion that is. Everyone else had treated space and time as the fixed stage and light as the puzzling actor. Einstein made light the fixed thing and let the stage bend. And the reason his version won is not that it was more elegant, though it was, but that it made predictions that turned out to be right, over and over, for 120 years, including many that nobody could test at the time. There is a nice historical footnote about the Michelson and Morley experiment, which is that Einstein was curiously vague about how much it influenced him. In different accounts at different times, he gave different impressions, and historians have argued about it ever since. He seems to have been driven at least as much by an aesthetic objection to an asymmetry in the equations of electromagnetism as by any specific failed experiment. That is worth mentioning because it complicates the tidy story. The usual telling has a decisive experiment producing a puzzling result, which a genius then explains. The reality was messier. The experiment was one input among several. The theoretical situation was already uncomfortable for independent reasons, and several people, including Lorentz and Poincare, had assembled large parts of the mathematics before Einstein. What Einstein contributed was the willingness to say that the mathematics meant what it said about space and time, rather than treating it as a computational trick to preserve the ether. And I find that a more useful model of how science works than the lightning bolt version. The pieces were mostly on the table. What was missing was somebody prepared to believe them. The ether, meanwhile, quietly disappeared, not disproved by a single experiment so much as made unnecessary. If light needs no medium, and the equations work perfectly without one, then there is nothing for the ether to do, and a thing with no job in physics eventually stops being mentioned. It is one of the cleanest examples of a concept that was central to a field and then simply evaporated, leaving no trace except in the history books and the name of a certain kind of network cable. So, we arrive at the modern position by a long road. Light has a finite speed, discovered by an irritated astronomer watching Jupiter. That speed does not depend on how you are moving, discovered by an experiment that found nothing. And the reason it does not is that space and time are not what we thought, proposed by a patent clerk who decided to take the null result at face value. Which brings us back to the question of what the number actually is, now that we know it is not a property of light and not a property of any medium. And that definitional move is not just administrative housekeeping. It is a clue about what C actually is, and now we arrive at the heart of tonight. Ask yourself why a speed can be a definition at all. Speeds are usually contingent facts about the world. The speed of sound depends on the air. The speed of a car depends on the engine. You cannot define those, but we defined C, and the physics community shrugged and accepted it because at some level everyone already understood what the number really represents. Here it is. The speed of light is a conversion factor between space and time. Let me unpack that, because it sounds abstract, and it is the most practical idea in the whole of relativity. We measure distance in one set of units, meters or miles, and we measure time in a completely different set, seconds or years, and we treat these as entirely different kinds of thing. That separation feels obvious. Space is over there. Time is later. They have nothing to do with each other. Relativity says that separation is a mistake and that space and time are two aspects of one thing. And if that is true, then measuring them in different units is exactly as arbitrary as measuring the width of a room in feet and its length in meters. If they are the same kind of quantity, you need a conversion factor to move between the units. A number that says how many meters of space correspond to 1 second of time. That number is C. And that is why physicists working in this area routinely set C equal to 1. They simply choose to measure time and distance in the same units. And once you do, the conversion factor disappears from the equations entirely, and a great deal of the apparent complexity of relativity evaporates with it. In those units, 1 second of time and 1 second of distance are the same size, and light travels 1 unit of space per unit of time, which is to say it travels at 45 degrees through space-time, and the famous constant is just the number 1. You already use a version of this. When you say a star is 4 light-years away, you are measuring distance in units of time. You are saying the distance is 4 years. Nobody finds that confusing. That is the conversion factor at work in ordinary language, and you have been using it comfortably for years without noticing that it is the deepest idea in 20th century physics. So, C is not fundamentally a speed, it is an exchange rate. And the reason it seems enormous, 300,000 kilometers per second, is not that light is fast. It is that our units are badly matched to each other. We invented the second based on the length of a day and the meter based on the size of the Earth, 2 quantities with no relationship to each other and none to the structure of space-time. The number is huge because our yardsticks are mismatched, not because the universe is doing something dramatic. If human beings had happened to measure distance in light seconds from the beginning, C would equal 1. And nobody would ever have called it a speed limit, and this whole subject would feel very different. Now, the second half of the idea, and this is the one that reorganizes everything. If space and time are the same kind of thing, measured in the same units, then motion through space and motion through time are the same kind of motion. And here is the claim that took me years to properly absorb, and which I would like to hand you tonight in a form that sticks. Everything in the universe is always moving through space-time at exactly c. Everything. Always. Without exception. You, lying in your bed, apparently motionless, are moving through space-time at the speed of light. All of your motion is currently directed through the time dimension. You are traveling into the future at 1 second per second, which is another way of saying you are moving through space-time at c, entirely in the time direction. Now start moving through space. Get up. Walk across the room. You have taken a tiny fraction of your total space-time motion and redirected it from the time direction into a space direction. And because the total is fixed at c, always, your motion through time must decrease by exactly the amount you diverted. That is time dilation. That is the whole of it. Not a strange effect that happens to fast things. Simply the fact that your space-time speed is fixed and you can point it at space or at time, and whatever you spend on one is unavailable to the other. At walking pace, the fraction you divert is so absurdly small that no clock ever built could measure the difference. At a substantial fraction of c, you are diverting a serious share, and your progress through time slows measurably. And at c itself, all of your motion is directed through space. None of it remains for time, and your clock stops entirely. Which is why massless particles travel at c. They have no rest mass, nothing anchoring them into the time direction, so their entire space-time motion is spent on space. And it is why nothing with mass can ever reach c. Not because there is a wall in the way, because reaching c would mean spending all of your motion on space and none on time. And a thing with mass cannot stop moving through time. It would have to stop existing in sequence. The speed limit is not a barrier. It is a budget. Let this be tonight's first long stillness, and it is a strange one, because I want to take you somewhere that cannot be visited even in principle. Imagine you are a photon, not riding along beside one, being one. You are created, perhaps in the outer layers of a star, and you set off. And here is what your journey is like. Nothing. That is not a poetic evasion. That is the actual answer the mathematics gives, and it is the most extraordinary consequence of everything we have just described. Because all of your motion is spent on space, and none remains for time, your clock does not run. Not slowly, not almost imperceptibly. It does not run. No time passes for you at all. So the photon that left a star in the Orion Nebula 1200 years ago, crossed 1200 light-years of vacuum, and ended tonight on the back of somebody's retina, did not experience 12 centuries of travel. From its own perspective, if it can be said to have one, emission and absorption were the same event. It was created and destroyed in the same instant. The entire journey, the whole span between a stellar surface and a human eye, took place in no time whatsoever and covered no distance whatsoever, because the same effect that collapses the duration collapses the length. Every photon that has ever existed, including the ones that have been traveling since the universe was 400,000 years old and now arrive as the faint microwave glow filling all of space, has had exactly the same experience. None. They are all, from their own point of view, being absorbed at the moment they are emitted. Physicists are careful here, and I should be too. Strictly, there is no valid reference frame for a photon. You cannot construct one because the mathematics that lets you sit in a moving object's perspective breaks down completely at sea and produces nonsense rather than an answer. So, saying a photon experiences no time is a limit rather than a description, an extrapolation of what happens as you approach sea rather than a report from a place anyone can stand. But it is the right extrapolation, and it tells you something real. As things move faster, their experience time shrinks towards zero, and at the limit, there is nothing left. Light does not travel across the universe. Light connects two points that, from its side of things, are touching. Come back from that and sit with what it implies about the sky, because it changes the picture. You have probably heard that when you look at a distant star, you see the past. That is true, and everyone says it. But notice what it looks like from the other end. The light does not experience a long wait. It is not old in its own terms. It is fresh. The delay exists entirely on our side because we are the ones with mass moving through time, forced to wait while the message crosses. So the universe is not sending us stale news. The universe is sending instantaneous messages that we, being slow objects made of matter, cannot receive promptly. The lateness is our condition, not the lights. And here is a related thing I find quietly astonishing about your own body, which is doing this right now. Every time you see anything at all, you are seeing the past. Not just stars. The screen or ceiling in front of you is being seen as it was a few billionths of a second ago. The far wall of the room, a few tens of billionths. This is far too small to matter for anything practical, and it is exactly as real as the 1200-year delay from the belt of Orion. There is no threshold below which the delay stops being real. Every act of perception you have ever performed has been an act of looking at the past, and there has never once been an exception, and there never can be. You have never seen anything as it is. Nobody has. Nobody will. That is not a defect of eyes, and it is not solved by better instruments. It is the geometry of the thing. Information takes time to cross a gap, always, and C is the fastest it can go. And so the present moment of anything at a distance is permanently, structurally unavailable to you. What you get is a letter, and the further away the sender, the older the letter, and there is no courier faster than the one already carrying it. Which brings us to the question underneath all of this, the one I promised at the beginning. Why should there be a limit at all? Why does the universe not simply let things be instantaneous? It seems on the face of it like an arbitrary and rather unhelpful restriction. And the answer turns out to be that it is not a restriction the universe chose. It is close to unavoidable. Here is one of the loveliest results in physics, and hardly anyone outside the subject has heard of it. Start with almost nothing. Assume only a couple of things so mild they barely feel like assumptions. First, that space is the same in every direction and every place, so an experiment done here gives the same result as one done a mile away or facing north instead of east. Second, that the laws of physics are the same for anyone moving steadily, so that if you are on a smoothly moving train with the blinds down, no experiment you can do inside the carriage will reveal that you are moving at all. That second one is not exotic. Galileo wrote it down in the 1600s using a ship rather than a train, noting that below decks with no view of the shore, everything behaves exactly as it does in port. Flies fly normally, water drips normally. Nothing gives the motion away. Now, from those innocuous assumptions and some careful mathematics, you can work out all the possible ways that measurements of space and time can transform between one steady observer and another. And the striking result is that there are only two possibilities, just two. Either there is no special speed, in which case velocities simply add the way our intuition says. Throw a ball at 10 miles an hour from a train doing 50 and the ground sees 60. That is the everyday world, and it corresponds mathematically to having an invariant speed that is infinite. Or there is a finite invariant speed, a speed that comes out the same for every observer regardless of their own motion, which is a genuinely bizarre property for a speed to have, and which forces space and time to mix into each other in exactly the way relativity describes. Those are the options. The universe had a choice of two, and the choice was not really about light. It was about whether the invariant speed is finite or infinite. And notice what that means. The existence of a universal speed limit is not an extra rule bolted onto physics. It falls out of assuming that space is uniform and that motion is relative. Almost everything else is fixed once you decide that number. If it is infinite, you get Newton, absolute time, a universal present moment, and no relativity at all. If it is finite, you get everything we have been describing tonight, and the value of the number sets the scale, but not the character. Nature picked finite. We do not know why. That is an honest gap, and I will not paper over it. There is no accepted explanation for why C has the value it has rather than some other, and there is a good argument that the question may not even be meaningful, since the number depends on our arbitrary units. What is meaningful is that it is finite rather than infinite, and nobody can tell you why. It is one of the places where physics currently stops and says, this is how it is. But we can say a great deal about what would happen if it were otherwise, and this is where it stops being abstract. Consider what an infinite invariant speed would mean. Every event in the universe would be simultaneous with itself everywhere. When a star exploded, the entire universe would know instantly. There would be a single universal present moment, the same for everybody, ticking forward together. and the word now would mean the same thing to you and to something in a distant galaxy. That sounds tidy, and it is what almost everyone intuitively believes the universe is like. It is also the thing that a finite sea destroys, and the destruction runs deeper than most people realize. Because if there is no infinite signal, then there is no way to establish who is right about what is happening at the same time as what. Two observers moving differently will genuinely disagree about whether two distant events were simultaneous, and neither is mistaken. Simultaneity turns out not to be a fact about the universe at all. It is a fact about your state of motion. There is no universal now, there is your now, and there is theirs, and they do not match. And no experiment can make them match, because the only tool you could use to compare them is a signal. And signals are limited by c. The finite speed of light dismantles the shared present. That is the price of it, and it is a much heavier price than a restriction on how fast rockets can go. But it buys something enormous in exchange, and that is where we go next, because it is the reason the whole arrangement holds together at all. What the finite speed buys is cause and effect. And this is the reason physicists have started calling c the speed of causality rather than the speed of light. Here is the problem it solves. We have just said that observers moving differently disagree about which distant events are simultaneous. That is unsettling, but survivable. What would not be survivable is if they disagreed about the order of events that are causally connected. If you and I could disagree about whether the window broke before or after the brick hit it, the universe would stop making any sense at all. And the remarkable thing is that relativity protects us from exactly that. And C is the mechanism. Work it through. Two events that are close enough in time and far enough apart in space that not even light could get from one to the other are called, in the jargon, space-like separated. For those events, different observers genuinely do disagree about the order. One says A came first, another says B, a third says they were simultaneous. And all are correct. That sounds like chaos until you notice the crucial detail. Those events cannot possibly have influenced each other. No signal could have crossed between them, because nothing outruns C. They are causally disconnected. And since neither caused the other, it does not matter in the slightest what order anybody puts them in. Nothing depends on it. Now take two events where a signal could have crossed, where one could have caused the other. Every observer, no matter how they are moving, agrees on their order. Every single one. The disagreement about time ordering is confined precisely and exclusively to pairs of events that cannot affect each other. That is not a coincidence. That is the structure of space-time arranging itself so that causality survives the loss of universal time. We gave up the shared present, and in return we kept the guarantee that causes precede effects for everybody, always. And this is why faster-than-light travel is a much more serious problem than it first appears, and why physicists are so much more hostile to it than the public expects. It is not that it would be difficult, or that it would take too much energy. It is that it would break the arrangement. If anything at all could travel faster than C, it could cross between two space-like separated events. Those are exactly the events whose order is not agreed on. So, you would have a cause and an effect whose sequence some observers see one way and others see the other way. And with a little arranging, using two such signals, you can construct a chain where an effect precedes its own cause in every frame. A message arriving before it was sent. The classic paradox, not as a story problem, but as a direct consequence of the geometry. This is the real reason the limit matters. C is not there to stop us reaching other stars. It is there if a physical constant can be said to be there for anything, to keep the universe's events in an order everyone can agree on. Take it away, and you do not get faster travel. You get a universe in which the word because stops working. There is a lovely piece of history attached to this, and it is worth telling because it shows the field behaving well under pressure. In 2011, an experiment in Europe called Opera, which fired beams of neutrinos from a laboratory in Switzerland through hundreds of miles of rock to a detector in Italy, reported something extraordinary. Their neutrinos appeared to be arriving about 60 billionths of a second earlier than light would have, faster than C. The collaboration did the right thing, and it is worth appreciating how right it was. They did not announce a revolution. They published the anomaly, said plainly that they could not find an error, and explicitly invited the rest of the world to find one because they did not believe it themselves. That is a rare and admirable way to behave with a career-defining result in your hands. And the world went looking. For months, this was the biggest story in physics, and eventually the answer came back, and it was crushingly mundane. There was a fiber optic cable carrying the timing signal from a positioning receiver to the experiment's master clock, and it was not fully seated in its connector, a loose plug. Correcting for it removed the effect entirely, and the neutrinos turned out to travel at very nearly C, exactly as expected, which is itself interesting because it means neutrinos have a very small mass, but a real one. I like that story enormously, and not as a joke at anyone's expense. The scientists behaved impeccably, the result was checked exactly as it should have been, and the system worked. But it is also a demonstration of how much rests on this one number. The apparent violation of C was, briefly, the most important scientific claim in the world, and the reason is everything we have just described. If it had held up, it would not merely have been a fast particle. It would have been a crack in causality. All of this can sound like a set of claims about extreme situations, remote from anything real. So let me show you 3 places where it is not remote at all, and where the whole structure is being confirmed continuously. The first is in your pocket, or your car, or on your wrist. Satellite navigation works by triangulation against a constellation of satellites, each broadcasting the time from an atomic clock aboard. Your receiver picks up several of these signals, notes that they were sent at slightly different times, and works out how far away each satellite must be, and from that, where you are. The whole system is a machine for turning timing into position, and it depends on knowing exactly how fast the signals travel, which is c. But here is the part that makes it a relativity experiment running permanently over your head. Those satellites are moving fast, at something like 8,000 miles per hour, which makes their clocks run slow relative to yours by a small amount. And they are also higher up in Earth's gravitational field, which makes their clocks run fast relative to yours by a rather larger amount, because gravity affects time too. The two effects work in opposite directions and do not cancel. The net result is that a satellite clock gains something like 38 millionths of a second per day compared to a clock on the ground. That sounds negligible. It is not, because the system converts time into distance using c, and c is enormous. An error of 38 microseconds corresponds to a position error of about 7 miles per day. Uncorrected, satellite navigation would drift badly wrong within minutes of being switched on and would be useless within an hour. So the correction is built into the system. It has to be. The engineers who designed it did not include relativistic corrections out of theoretical interest. They included them because the thing does not function otherwise. Every time your phone tells you where you are, it is relying on the geometry we have been discussing being exactly right. And it is right continuously everywhere for billions of people. The second place is even more direct, and it involves particles raining down on you as you lie there. The upper atmosphere is constantly being struck by cosmic rays, and those collisions produce particles called muons, which are essentially heavy electrons. Muons are unstable and decay quickly, with an average lifetime of about 2 millionths of a second. They are created around 10 miles up, and they travel downward at very close to sea. Now, do the arithmetic the old-fashioned way. At nearly the speed of light, in 2 millionths of a second, a muon covers about 6/10 of a mile. It is created 10 miles up, so essentially none of them should reach the ground. The number arriving at sea level should be a tiny fraction of a percent of the number created, but they arrive in enormous quantities. Hundreds pass through your body every minute. Right now, you are being gently rained on by particles that, by the naive calculation, should have decayed miles above your head. The reason is time dilation, and it is not subtle at these speeds. From our point of view, the muon's internal clock is running slow, so it lives much longer than 2 microseconds in our reckoning and has time to make the trip. From the muon's point of view, its lifetime is perfectly normal, but the 10 miles of atmosphere is contracted to a much shorter distance, so it has less far to go. Both descriptions are correct. They are the same fact seen from 2 frames, and either way the muon arrives. This was measured properly in the 1940s and has been confirmed constantly since. It is one of the most direct demonstrations there is, and the apparatus is the sky. And the third place is the one that pays for a lot of physics: particle accelerators. At the largest of them, protons are accelerated until they are traveling at more than 99.9999% of c. And what the engineers observe every day is exactly what relativity predicts. As the protons approach C, additional energy does not meaningfully increase their speed anymore. It goes into their energy and their effective mass instead. You can pour in as much as you like and the speed creeps closer to C by ever smaller amounts and never arrives. If speed simply added the way intuition says, those machines would not work at all. The timing of every magnet, the frequency of every accelerating cavity, all of it is calculated using relativity, and the machines run. So, the picture we have built tonight is not a philosophical stance about the nature of space. It is load-bearing engineering. Satellites correct for it, particles demonstrate it, accelerators are designed around it, and all three would fail visibly and immediately if the geometry were different. There is one objection to all of this that comes up more than any other, and it deserves a proper answer rather than a wave of the hand, because on the face of it, it looks like a direct violation of everything we have just said. Quantum entanglement. You will have heard some version of it. Two particles are prepared together in a particular way, then separated by any distance you like, across a room or across a galaxy. Measure one, and the other is instantly affected. Einstein himself called it spooky action at a distance, and he meant it as a complaint because it looked to him like evidence that quantum mechanics must be incomplete. And the effect is real. This is not a misunderstanding or a pop science distortion. It has been tested repeatedly and with increasing rigor, most decisively in a series of experiments that closed off the remaining loopholes one by one, and the work won a Nobel Prize in 2022. The correlations are there. They are stronger than any arrangement of pre-agreed instructions could produce, and they do not weaken with distance. So how does that not break the speed limit? The answer is precise, and it is the key to the whole thing. The correlation is instantaneous. The information is not. And you cannot use the correlation to send anything. Here is why. Suppose you and I share a pair of entangled particles and I am on Earth, and you are somewhere far away. I measure mine, and I get a result. And my result is random, genuinely random, with no way for me to influence which outcome I get. Your particle is now correlated with mine, but you have no way of knowing that anything has happened, because when you measure yours, you also get a random-looking result. Your measurements look exactly the same whether I have measured mine or not, whether I measured it an hour ago or never. The correlation only becomes visible when we compare our lists of results. And to compare the lists, one of us has to send the other a message, by ordinary means, at or below C. So no information crosses, nothing you could use to signal, warn, instruct, or communicate travels faster than light. This is not an accident or a lucky escape. It is a theorem, and it has a name, the no communication theorem, and it is provable from the structure of quantum mechanics itself. The universe is arranged so that the correlations are unusable for signaling. I have always found that a strange and rather elegant arrangement. It is as though the universe permits a kind of coordination that transcends distance while making absolutely certain you cannot exploit it for anything. two dice, thrown light years apart, that always land on matching faces, and no way whatsoever to use that to send a message. And notice what this does for causality, which is the thing we established C protects. Because no information crosses, no cause can precede its effect, and the whole structure of ordered events survives intact. Entanglement does not threaten the causal order, precisely because of the restriction that makes it so frustrating to anyone hoping for a faster-than-light telephone. There is a broader point worth taking from this, and it applies to almost every claim you will encounter that something beats the speed of light. There are several things in physics that in some sense go faster than C, and every one of them turns out, on inspection, to carry no information. The point where a pair of scissors closes can move along the blades faster than light if the scissors are long enough and you close them fast enough. But that point is not a thing, it is a geometric coincidence, and you cannot send a message with it. Sweep a laser pointer across the face of the moon and the spot can cross the surface faster than C, but nothing travels along that path. It is a sequence of separate photons arriving. Certain quantum tunneling experiments produce timings that look superluminal and turn out, when analyzed carefully, to transmit nothing. The pattern is completely consistent. Shadows, spots, phases, correlations, and geometric points are all free to exceed C, because none of them is a thing moving and none of them can carry a message. Anything that could actually tell you something never exceeds it. That is the real content of the limit, stated as precisely as I can manage. It is not a restriction on how fast objects may travel. It is a restriction on how fast a cause can reach an effect. And everything that appears to break it turns out, without exception, to be something that cannot cause anything. There is one more category worth mentioning, because it is the honest exception, and physicists do take it seriously enough to have given it a name. Suppose there were a particle that had never traveled slower than light, not something that accelerates past the limit, which we have established is impossible, but something that was born on the far side of it and has always been there. For such a particle, the limit would work in reverse. It could never slow down to C, in the same way we can never speed up to it, and it would be trapped above the barrier exactly as we are trapped below. The name for such a thing is a tachyon, and the mathematics permits it in the sense that you can write the equations down without anything obviously breaking. What you get is a particle whose mass, in the usual formulation, comes out as an imaginary number, and which speeds up as it loses energy, which is a strange enough behavior to make anyone suspicious. Nobody has ever detected one, and searches have been made. But the reason physicists do not expect to find one is not the absence of evidence. It is that a tachyon would be able to cross between events whose order observers disagree about, and everything we discussed a moment ago would come apart. You could, with two of them and some careful arrangement, send a message into your own past. The objection is not experimental. It is that the universe would stop being consistent. The word survives in modern physics, but with a completely different meaning that is worth knowing, because it causes endless confusion. When a physicist today talks about a tachyonic field, they almost never mean a faster-than-light particle. They mean a field sitting in an unstable configuration, poised to roll into a lower energy state, which is a perfectly ordinary situation and shows up in the theory of how particles acquire mass. The name is a historical leftover from an early misreading of what the mathematics was describing, so the tally holds, with one hypothetical asterisk that nobody expects to cash. Shadows, spots, and correlations may exceed C because they carry nothing. Real particles do not, and the one theoretical loophole is rejected not because we have looked and failed to find it, but because admitting it would cost us the thing the limit exists to protect. Now I want to show you something about the speed of light that sounds impossible when you first hear it, and which is completely accepted physics, and which almost nobody outside the subject knows. Nobody has ever measured the speed of light, not once, not Römer, not Fizeau, not Michelson, not any modern laboratory. And it is not a question of precision. It is that the measurement cannot be made even in principle. Let me explain what I mean, because I am being precise rather than provocative. Every measurement of the speed of light that has ever been performed has measured a round trip. Light goes out to a mirror and comes back to the detector, and you time the whole journey and divide by the total distance. That is what Fizeau did with his toothed wheel. That is what every laboratory method does, and it works beautifully and gives the number we all know. But what you have measured is the average speed of the outward and return legs. You have not measured how fast light traveled in either direction individually. Now, obviously, you think, just measure one leg. Put a clock at each end, note the time light leaves and the time it arrives, subtract. And here is the trap. To do that, the two clocks have to be synchronized. They have to agree on what time it is. And how do you synchronize two clocks separated by a distance? You have to send a signal between them and correct for how long the signal took to travel. But the whole point of the experiment is to determine how long a signal takes to travel in that direction. You need the answer in order to set up the experiment that finds the answer. It is perfectly circular, and there is no way out of it. Every proposed solution turns out to smuggle the assumption back in somewhere. Synchronize the clocks side by side and then slowly move one to the far end. And the moving clock's time is affected by its motion in a way that depends on the very thing you are trying to measure. So the one-way speed of light is not something we know. It is something we assume, and Einstein said so explicitly. He chose as a convention to define the one-way speed as equal in both directions because it is the simplest choice and makes the mathematics clean. That choice is called Einstein synchronization, and it is baked into the whole edifice, which raises an unsettling possibility that is genuinely open. It is entirely consistent with every experiment ever performed that light travels at, say, half the speed we think in one direction and infinitely fast coming back, or any other combination that averages out correctly on the round trip. There is no observation, past or possible, that could distinguish these scenarios from the standard one. Now, I want to be careful about how I present that, because this is a subject where the popular telling tends to overreach. What is genuinely true and uncontroversial among physicists is that the one-way speed depends on a synchronization convention and cannot be measured independently of one. That is not fringe. It is standard. It has been understood for over a century, and Einstein was completely upfront about it. What is not true is that this reveals some hidden flaw in relativity, or that physics is built on an unexamined guess. The convention is a choice of coordinates, like deciding which way is north or where to put the prime meridian. Choose a different synchronization and the equations get uglier. Various things acquire strange asymmetries, but every prediction you can actually test comes out identical. Nothing observable depends on it. So it is not a secret that might one day be uncovered. It is a demonstration that part of what we call the speed of light is a bookkeeping decision rather than a fact about the world. And that, I think, fits rather beautifully with everything else tonight. We started by noticing the name was wrong, that C is not really about light. Then we found it is a conversion factor between space and time rather than a speed. Then that it is fixed by definition rather than measured. And now that even the directional part of it is a convention we adopted for convenience, layer by layer, the thing we were taught to think of as a physical speed keeps turning out to be something more like a structural feature of reality that we have been describing in the language of speed, because that was the first way we noticed it. The number is real. The universe absolutely does have a maximum rate at which influence propagates, and everything we observe confirms it. But nearly everything about how we talk about it, the name, the units, the framing as a limit, the directional symmetry, turns out to be scaffolding we put up ourselves. Let us deal with an objection that may have been forming, because it is the most common one, and the answer illuminates everything else. Light slows down. You know this. It is not even exotic. Light travels more slowly through water than through air, and more slowly through glass than through water, and that is the entire reason lenses work. A lens bends light precisely because the light changes speed crossing the boundary. Every pair of spectacles, every camera, every telescope humanity has ever built depends on light going slower in the glass. So how can C be an absolute constant if light routinely travels at other speeds? The answer is that light does not, in fact, slow down. What slows down is the light beam, which is not the same thing, and the distinction is one of the nicest bits of physics I know. Here is what actually happens inside glass. The photons travel between the atoms at exactly c, always, because they are massless and have no other option. But glass is not empty. It is full of atoms, and each atom is a cloud of electrons, and an electromagnetic wave passing through cannot ignore them. The oscillating field pushes the electrons oscillate in response, and oscillating charges radiate their own light. So the wave that emerges on the far side is not simply the original wave, it is the sum of the original wave and all the new little waves generated by every disturbed electron along the way. And when you add those together, accounting for the phases, the combined wave has its peaks slightly delayed compared to where they would have been in vacuum. The whole pattern advances more slowly, not because anything is traveling slower than c, but because the emerging wave is a fresh superposition continuously rebuilt, and the rebuilding introduces a lag. The photons never slow down. The message does because it keeps being handed off, and once you understand that, you can do something spectacular with it. Physicists have taken the effect to extremes. By preparing certain gases in very particular quantum states, researchers have slowed light pulses to walking pace, then to a crawl, and eventually they managed to stop light altogether, holding a pulse motionless in a cloud of ultra-cold atoms for a fraction of a second and then releasing it to continue on its way. Headlines describe this as stopping light, which is forgivable and slightly misleading. What actually happens is that the light's information is transferred into the quantum states of the atoms and stored there, and then handed back to a new pulse of light on the way out. The photons are not sitting still in a jar. The pattern is being kept in the atom's arrangement for a moment, but notice what this proves rather than what it seems to. Even in the most extreme laboratory conditions, where light appears to stop entirely, the underlying constant never budges. Every photon involved is still doing exactly c between interactions. The variable thing is how much the material interferes. The invariant thing is c, and it has never once been observed to be anything else, in any material, in any laboratory, anywhere. Which is a good moment to notice how relentlessly this shows up. Let me lay out the tally. Light travels at c because photons are massless. Gravitational waves travel at c, and they contain no light at all. Gluons travel at c. The whole structure of space and time is built around c as the conversion between them. Causality propagates at c, and there is one more place it appears that everybody knows, and almost nobody connects to any of this. The most famous equation in the world: energy equals mass times the speed of light squared. Ask yourself what the speed of light is doing in an equation about mass and energy. There is no light in that equation. It concerns a lump of matter sitting still and how much energy it represents. Why should the speed of a photon have anything to say about that? Because, once again, it is not the speed of a photon. It is the conversion factor. Just as c converts between meters and seconds, c squared converts between the units of mass and the units of energy. The equation is not saying that mass turns into light. It is saying that mass and energy are the same thing measured in different units, exactly as space and time are. And here is the exchange rate. That is why the number is so enormous when you convert. A tiny amount of mass corresponds to a colossal amount of energy, not because something dramatic happens, but because our unit of mass and our unit of energy are wildly mismatched in scale, in the same way our meter and our second are. So the most famous equation in physics is a units conversion. And the reason it changed the 20th century is that nobody had previously realized those two quantities were the same kind of thing at all. Every time C appears anywhere in physics, it is doing that same job. It is stitching together two things we thought were separate and telling you the rate. Space to time, mass to energy, cause to effect. It is the universe's exchange rate, and it turns up wherever two apparently different aspects of reality turn out to be one aspect seen from two sides. There is a question sitting underneath everything we have said tonight that I have not yet touched, and it is the obvious one to ask about any constant. Has it always been the same? We have been treating C as fixed for every observer, which we have justified at length, but also implicitly fixed across all of time. And that second assumption is doing a great deal of quiet work. Every distance we quote to a galaxy, every age we assign to the universe, every inference about the early cosmos assumes the number was the same billions of years ago as it is tonight. How would we ever check? We cannot go back and measure it. And we established earlier that C is now defined rather than measured, which makes the question sound almost meaningless. The way physicists get around this is clever. Rather than asking whether C has changed, they ask whether the fine structure constant has changed, the dimensionless number we met earlier that combines C with the electron's charge and the quantum of action. Because it has no units, a change in it would be a genuine change in the universe rather than a change in our yardsticks. And because it controls the strength of electromagnetism, it determines the exact wavelengths at which atoms absorb and emit light, which gives us a method. Atoms billions of light years away are emitting and absorbing light right now, and that light has been traveling toward us since the early universe. If we measure the precise pattern of wavelengths in it and compare with the same atoms in a laboratory today, any shift in the pattern beyond the expected stretching would indicate that the constant was different back then. This has been done extensively using the light of distant quasars filtered through intervening gas clouds, and the answer from most analyses is no detectable change. Some groups have reported hints of tiny variation at a level of a few parts in a million over billions of years, and those claims have been contested, with other teams using different instruments finding nothing and pointing to possible systematic errors. The honest summary is that there is no accepted evidence of variation, and the limits are extremely tight. There is also a wonderful piece of evidence from the ground, and it is my favorite because of where it came from. In 1972, workers at a uranium processing plant in France noticed that ore from a mine in Gabon was slightly depleted in the isotope used for reactors, not by much but consistently, and uranium ore does not vary. The investigation that followed found something extraordinary. Around 2 billion years ago, in a place called Oklo, Groundwater seeping through a rich uranium deposit had moderated neutrons well enough to start a self-sustaining nuclear chain reaction. A natural nuclear reactor running in the rock, cycling on and off for hundreds of thousands of years. And that ancient reactor is a physics experiment left running for us. The details of how those reactions proceeded, and therefore the precise mix of isotopes left behind, depend sensitively on the strength of the fundamental interactions. Analyze the residue and you can constrain how different the constants could have been 2 billion years ago. The answer is that they were the same to a precision of parts in 10 million or better. So we have a natural reactor in Africa and the light of distant quasars, two completely unrelated methods, sampling different epochs and both saying the same thing. The constants have held. The universe has not been quietly adjusting its own rules. I find that a rather comforting note to arrive at this far into the night. Everything we have described, the budget through space-time, the conversion between space and time, the protection of cause and effect, has apparently been in force, unchanged, for essentially the whole life of the universe. The rules were set early, or set at the beginning, and they have not wavered while galaxies formed and stars lived and died, and something on a small planet eventually worked out what the rules were. There are serious theories in which the constants do vary, and they are not crank ideas. They are legitimate attempts to explain why the numbers have the values they do. But so far, every place we have looked, the universe has come back with the same answer. The same everywhere, for everyone, and apparently for always. So let us ask the question that has probably been sitting at the back of your mind since we began. What if the number were different? This is worth doing carefully because it is a place where popular science often goes slightly wrong. And the careful version is more interesting than the loose one. The loose version says that if the speed of light were slower, everything would be different. And there is a genuine subtlety here, which is that asking what would happen if a number with units were different is not quite a well-posed question. The value of c depends on what a meter is and what a second is, and those are human choices. Change the number without changing anything else, and you have merely changed your units, which changes nothing about the universe. Physicists deal with this by working with dimensionless combinations, numbers that come out the same regardless of what units you use. And there is one that contains c and is genuinely fundamental, called the fine structure constant, which is roughly 1 part in 137. It combines the charge of the electron, the quantum of action, and the speed of light into a pure number with no units at all. That number is not a human choice. It is a fact about the universe. And that number controls the strength of the electromagnetic interaction, which is to say, it controls how tightly electrons are bound to nuclei, and therefore the size of atoms, and therefore the whole of chemistry. Now we can ask the question properly. What if that number were different? Change it much and things go badly. Make electromagnetism substantially stronger, and the fusion processes in stars are disrupted, the chain that builds carbon inside stars becomes difficult or impossible, and you do not get the elements life is made of. Make it substantially weaker, and chemical bonds become too feeble to hold complex molecules together at any reasonable temperature. Either way, you lose a universe that can build complicated things. I want to be measured about this, because it is easy to slide into a claim that the universe was tuned for us, and the honest scientific position is more modest. There is real debate about how narrow the windows actually are. Some of the calculations depend on varying one thing while holding everything else fixed, which may not be legitimate. And there are proposed explanations ranging from a multitude of universes with different values to a deeper theory that fixes the number for reasons we have not found yet. Nobody knows. What is safe to say, and it is quite enough, is that the number is not obviously arbitrary in its consequences. It sits somewhere that permits chemistry, and chemistry is not a given. But here is the part I actually want to leave you with, which requires no speculation at all, because it is about the universe we definitely have. The finite speed of light is the reason the universe is comprehensible. Consider the alternative seriously. If C were infinite, every event anywhere would affect everything else immediately. There would be no delay, no insulation, no separation between here and there. Every particle in the universe would be in instantaneous contact with every other particle. The night sky would not show you the past because there would be no past to show, only a single universal present in which everything is simultaneously connected to everything. And in such a universe, you could not do physics. You could not isolate a system because nothing is isolated. You could not run an experiment in a laboratory and expect the result to mean anything, because your laboratory would be in immediate contact with a supernova on the other side of the galaxy. Science is possible because things are separated, and things are separated because signals take time. The finite speed of light is what gives the universe local structure. It is why there is such a thing as a neighborhood, a region, a system with an inside and an outside. It is why events have a limited sphere of influence that expands at a knowable rate. It is why a thing can happen over there without immediately being your problem. We spend a lot of energy resenting this number. It is the reason the stars are unreachable, the reason a message to a probe at Neptune takes 4 hours, the reason we will probably never visit anything beyond our own solar system. All of that is true, and I have spent whole nights on it. But the same number is the reason there are separate things at all. It is what makes a universe rather than an undifferentiated, simultaneous everything. The isolation that frustrates us is the same isolation that lets a planet form quietly in a corner and lets chemistry proceed at its own pace, and lets a species evolve on a small rock for 4 billion years without being interrupted by the rest of creation. The speed limit is not a wall built around us. It is the thing that made the room. Before we close, there is one consequence of all this that gets far less attention than it deserves, and it is the hopeful one. So I have saved it. The speed limit is usually presented as the thing that makes the galaxy unreachable. And in one sense it is. But the way it makes things unreachable is more subtle than most people realize, and there is a loophole hiding inside it that requires no new physics at all. Here is the standard picture. The nearest star is over 4 light years away, so at best the trip takes more than 4 years. The center of the galaxy is 26,000 light years away, so a journey there takes at least 26,000 years. Therefore, the galaxy is off limits to creatures who live for 80 years or so. That is the usual conclusion, and it seems airtight. But notice whose clock we just used. 26,000 years is how long the trip takes, as measured by someone who stays behind. It is not how long the trip takes for the traveler, and we have spent tonight establishing that those are different numbers, and that the faster you go, the more different they become. Remember the budget. Divert enough of your space-time motion into space, and your progress through time slows enormously. Push close enough to see, and the effect is not a minor correction, it is dramatic. And the distance shrinks too, from your point of view, because the contraction and the dilation are the same fact, seen from either end. Work out the numbers for a ship that could accelerate steadily at a comfortable 1 gravity, which would also solve the problem of having no weight aboard, and the results are startling. Accelerate at that rate for about a year, and you are already at a substantial fraction of c. Keep it up, and the outside universe's clocks race ahead while yours ticks normally. On that kind of profile, accelerating for the first half and decelerating for the second, a traveler could reach the nearest star in something under 4 years of their own experienced time. They could reach the center of the galaxy in roughly 20 years of their own life. They could cross to the Andromeda galaxy, 2.5 million light years away, in something like 30 years aboard. Nothing in that violates any rule. At no point does the ship exceed c. Every outside observer sees it traveling slightly slower than light the whole way, taking 2.5 million years to reach Andromeda, exactly as the speed limit demands. It is only the traveler's own clock that permits the journey to fit inside a life. Now, I want to be honest about why this is not a plan, because it would be easy to leave that out, and it would be misleading. The energy required is preposterous. Sustaining 1 gravity of acceleration for decades demands quantities of fuel that dwarf anything we can construct, and the closer you get to C, the worse the requirement becomes. Then there is the problem we have discussed on other nights, that at those speeds the thin gas between the stars becomes a lethal radiation beam. And there is the price nobody can pay in currency, which is that you can go, but you can never come back to the world you left. Return to Earth after your 30-year trip, and 2.5 million years have passed here. The journey is one way in time, even when it is round trip in space. So it is not a proposal. But it matters as a fact about the universe, and here is why I wanted to end on it. The speed limit does not actually forbid crossing the galaxy within a lifetime. It only forbids doing it without consequence. The distances are survivable from the inside, What is not survivable is the relationship with everything you left, because the limit does not stop you traveling, it stops you staying connected while you do, which is, when you turn it over, exactly the same thing the number has been telling us all night. It is not a wall around us. It is the rule that separates here from there, and now from then, and it charges the same toll everywhere. Cross a great distance, and you pay in time. Stay put, and you pay in reach. There is no arrangement in which you get both, and that is not a cruelty. It is simply what it means to live in a universe where influence travels at a finite rate. Let this be tonight's second stillness, and it is about where you are sitting right now in the structure we have been describing. Physicists have a shape for this. It is called a light cone, and once you see it, you cannot unsee it, and it is the most honest picture of your situation that exists. Picture yourself at a single point, here, now. From that point, imagine light expanding outward in every direction, a sphere growing at sea. As time passes, the sphere gets larger. If you draw that on a diagram with time running upward, the expanding sphere traces out a cone opening upward into the future. Everything inside that upward cone is your future, not the future in general, your future. It is the complete set of every event you could possibly influence, every place a message from you could reach, every outcome your existence could ever affect. Anything outside that cone is permanently beyond your reach, forever, no matter what you do or how long you wait, because reaching it would require outrunning sea. And there is a matching cone opening downward into the past. That one contains every event that could possibly have influenced you. Everything that made you, everything you could ever have known about, the entire causal ancestry of this moment. Anything outside it has no bearing on you whatsoever, and never did. Now here is the part that lands. Everything else, the whole enormous remainder of the universe, is in neither cone. Physicists call that region elsewhere, which is a lovely piece of understatement. It is not your past and it is not your future. It cannot affect you and you cannot affect it. And crucially, as we discussed earlier, there is no fact of the matter about whether those events are happening now, because different observers order them differently, and none of them is wrong. The overwhelming majority of the universe at any moment is in your elsewhere. Sit with the shape of that for a while, because it is a strange kind of solitude, and I do not think it is a sad one. You are at the tip of two cones, one gathering everything that made you, and one containing everything you might touch. And around you in every direction is a vast region that is simply not on speaking terms with this moment. And the cones are not metaphors, they are the actual geometry. That is genuinely the structure of the space-time you are lying in. And every object in the universe has its own pair, and they overlap and interlock, and the entire causal history of everything is the pattern of those overlaps. Notice, too, that the cone is opening. Every second you wait, the sphere of things you could have influenced grows by another light second in every direction, Right now, as you lie there, the boundary of everything you could ever affect is expanding outward, past the moon, past the planets, out into the dark, at 300,000 kilometers per second, and it will keep going long after you stop. Anything you did today is already a shell of consequence 100,000 million kilometers across, spreading, and it will never stop spreading. That is the other side of the limit. Yes, it fences you in. It also means that nothing you do is ever entirely local. The influence propagates outward at the maximum rate the universe permits forever. And even when it has thinned to nothing measurable, the causal boundary is still out there expanding. Come back now to the room, because the last thing worth saying is small and immediate. The light from your ceiling reached you a few billionths of a second ago. If someone is in the room with you, you are seeing them very slightly in the past, and they are seeing you the same way. And neither of you has ever seen the other as they actually are at this instant. That delay is small enough to be irrelevant to your life, and it is exactly as real as the 1,200 years from Orion's belt. Everyone you have ever loved, you have only ever seen slightly late. That is not sad, and it is not a limitation of your eyes. It is what it means to be a thing with mass in a universe where influence has a finite speed. We are all of us permanently a few nanoseconds behind each other, and there has never once been an exception, and it has never mattered in the slightest. There is one more delay I want to bring in before the end, and it is closer than any of the others because it is happening inside your head. We have spent the night establishing that everything you see arrives late, and that the lateness is structural and unavoidable. But the delay from the ceiling to your eye is a few billionths of a second, which is small enough to be a philosophical curiosity rather than anything you could notice. The delay inside you is not. When light lands on your retina, the signal has to be converted into a nerve impulse and carried to the back of your brain and processed before anything reaches awareness. And nerve signals are slow. Not slow compared to light, slow compared to almost anything. The fastest nerve fibers in your body carry signals at something like 100 meters per second, which is roughly the speed of a fast train, and many carry them far more slowly than that. Compare that to 300 million meters per second, and the difference is a factor of millions. The result is that the moment you experience as now is assembled from information that is already tens or even hundreds of milliseconds old. Estimates vary depending on what exactly you are measuring, but the delay between light striking the eye and a conscious visual experience is somewhere in the range of 1/10 of a second. That is not a rounding error. That is a substantial and easily measurable lag. And it gets stranger, because your senses do not all run at the same speed. Sound reaches your brain faster than vision does after the initial transduction. Touch from your foot takes longer to arrive than touch from your face, simply because the nerve is longer. And yet your experience does not feel staggered. You do not perceive the world arriving in a scattered sequence of differently delayed channels, so your brain does something remarkable and slightly unnerving. It waits and it assembles, and it constructs a single, coherent moment out of inputs that arrived at different times, and it presents that construction to you as the present. Which means the now you are experiencing is not a moment at all. It is a reconstruction built out of stale data, smoothed and synchronized and served up with a confident label saying this is happening currently. It is a very good reconstruction. It is accurate enough to catch a ball and cross a road and read a face. But it is late, and it is manufactured, and there has never been a single instant in your life when you were experiencing the actual present. I find that a rather beautiful place for tonight to arrive at, because look at the symmetry of it. Out there, the finite speed of light means you can never see anything as it is. The stars are old news, the room is nanoseconds behind, and the universe is a stack of letters posted at different times and arriving in a jumble. And in here, the finite speed of nerves means you can never experience anything as it happens. Your own present moment is assembled after the fact from signals that have already been traveling for a tenth of a second. The universe delays the message on the way in, and you delay it again on the way through. And what you get at the end is a careful reconstruction of a moment that has already passed. Nobody has ever been present for their own life in the strict sense. Not once, not for an instant. Everyone who has ever lived has been running slightly behind, watching a rendering of a world that has already moved on, and it has never once mattered. That is the part that redeems it. The delay is universal. It applies to everyone equally, and since everything you compare against is delayed by the same amount, the whole system is perfectly consistent from the inside. You are not being deceived. You are simply reading a message that took a moment to arrive in a universe where every message does. And there is one more place the limit shows up that almost nobody thinks of as physics at all, which is inside the machine you are probably holding, or the one that is streaming this to you. Computers are limited by the speed of light, not in some far-off theoretical sense. Right now, as a hard engineering constraint that shapes how they are built. Here is the arithmetic. In 1/1000th of a second, light travels about 30 centimeters. Rather less than that in the copper and silicon of an actual circuit, where signals propagate at perhaps 1/2 to 2/3 of C. So in 1 nanosecond, a signal inside a computer covers something like 15 or 20 centimeters, the width of a handspan. Now consider that a modern processor runs at several billion cycles per second, which means each cycle lasts a fraction of a nanosecond. In that time, a signal can cross only a few centimeters of chip, which means that within a single tick of the clock, one side of a processor cannot communicate with the other side. The far corner of the chip is, for that instant, causally out of reach, not because the engineering is imperfect, because the message physically cannot get there in time. This is a genuine and well-known design constraint, and it is one of the reasons processors stopped simply getting faster and started getting wider instead, with multiple cores working in parallel. Making the clock faster stopped helping. partly because of heat, and partly because at some point a signal cannot cross the component within a cycle, no matter what you do. So instead of one enormous fast thing, you build several smaller things close together, precisely so that the distances stay short enough for the speed of light to permit it. Data centers run into the same wall at a larger scale. The delay in getting a request from one continent to another is dominated not by processing, but by propagation. And there is no engineering fix, because the fiber is already carrying light at close to the maximum. Financial firms have spent enormous sums laying straighter cables and building microwave relays between exchanges, not to make anything faster in any conventional sense, but to shave milliseconds off a delay that is set by geometry and sea. There was a famous project to lay a cable across the Atlantic whose entire commercial justification was a saving of a few thousandths of a second. I find this quietly delightful, because it is the same number we have been discussing all night, the one that governs neutron-star mergers and the causal structure of space-time, turning up as a practical nuisance in the design of a mobile phone. And it has an implication that is worth stating plainly. There is a hard ceiling on computation that has nothing to do with cleverness. If you want a computer to do more, you can make it smaller so signals have less far to go and eventually you hit the size of atoms. Or you can make it bigger and parallel, and then the parts cannot talk to each other quickly. Those two pressures squeeze from opposite directions and the space between them is set by C. Every computer that has ever been built and every computer that ever will be lives inside that squeeze. The universe has an opinion about how much thinking can happen in a given volume in a given time, and the opinion is enforced by the same constant that stops us reaching the stars, which is, I think, the last thing to notice about this number before we close. We started with it as a fact about light. We found it as a fact about space-time. And it turns out to be a fact about almost everything at every scale in places that seem to have nothing to do with astronomy at all. The size of an atom through the fine structure constant, the energy in a kilogram of matter, the order of events, the reach of your influence, the delay in your own perception, the design of a processor, the maximum useful width of a chip. Pull on that one thread and the entire fabric moves. Now, as we finally come to the end of tonight, let us gather the whole thing up, because I think this is one of those subjects where the ordinary understanding is not so much wrong as upside down, and turning it the right way up changes rather a lot. We were taught that there is a speed limit, and it is the speed of light. Almost every part of that sentence turns out to be misleading. It is not really a speed limit in the sense of a rule that stops things going fast. It is a budget. Everything is already moving through space-time at exactly that rate, always, and all any of us ever do is choose how much of that motion to spend on space and how much on time. Sitting still, you spend it all on time. That is why you age. Move quickly, and you divert some, and your clock slows by precisely the amount you diverted. Massless things spend the lot on space, and no time passes for them at all. And it is not the speed of light. Light travels at that speed for the unremarkable reason that photons have no mass, and massless things have exactly one available speed. Gravitational waves, which contain no light whatsoever, travel at the same rate. And we know that because a collision 130 million light-years away sent both signals racing, and they arrived less than 2 seconds apart. If the number belonged to light, gravity would have no reason to respect it. What it actually is, underneath all of it, is a conversion factor. It tells you how many meters of space correspond to 1 second of time, which is only a meaningful question if space and time are the same kind of thing, which is exactly what it is telling you. And when it appears in the most famous equation in physics, it is doing the same job again, converting between mass and energy, because those turn out to be the same kind of thing too. Everywhere that constant appears, it is stitching together two things we thought were separate. The number itself is no longer even measured. We measured it for 3 centuries, from an irritated Danish astronomer watching Jupiter's moon run late, through an experiment that famously found nothing at all, and then, in 1983, we stopped, defined it as exact, and rebuilt the meter out of it. The most measured quantity in physics became the ruler, and the reason any of it is like this comes down to a choice the universe made that nobody can explain. Given only that space is uniform and that motion is relative, there are exactly 2 possible universes. One where the invariant speed is infinite, and one where it is finite. Infinite gives you Newton, a universal present moment, and instant connection between everything. Finite gives you relativity, a personal now, and separation. We got finite, and we mostly resent it because it puts the stars out of reach. But look at what it buys, because that is where I would like to leave you. Cause always precedes effect for everybody, and no observer anywhere ever sees the effect first, and the only pairs of events people disagree about are the ones that could not have influenced each other anyway. The finite speed is what protects the order of things. Take it away, and you do not get faster travel. You get a universe where the word because stops meaning anything. And it is what makes there be separate things at all. A universe with instantaneous connection has no neighborhoods, no isolated systems, no here as distinct from there. Every experiment would be contaminated by every supernova. The delay that frustrates us is the same delay that let a quiet planet form in a corner and run its own chemistry undisturbed for 4 billion years until something on it woke up and started asking why the sky is dark. So here is tonight's cascade. It was never about light. It was about the exchange rate between space and time. It was never a wall. It was a budget you are spending right now. It was never measured. In the end, we defined it. It never had to be finite, and it is. And the price of it being finite is that nobody will ever see anything as it is. And the reward is that there isn't anything to see. Thank you for spending this night taking one number apart with me. I hope it landed the way I meant it, which is not as a limit but as a piece of architecture. If sleep has been circling while we talked, let it settle now. Nothing about this needs holding, and when you wake up and light from a window reaches your eye a few billionths of a second after it left the glass, and your brain assembles that into a morning about a tenth of a second after it happened, you will be doing the same thing every object in the universe has been doing since the beginning. Receiving the past at the fastest rate the universe permits and calling it now. Sleep well, a few nanoseconds behind everything. Good night.